Hi, everyone. Thanks for staying. It's nice. So, let's see. This is a ballroom, so the first dance is going to be salsa. Who joins me? No, I'm just kidding. There's a very important analogy I want to make actually in my presentation between the dance. I don't know who of you likes to dance. Sure, we are hackers. No, I do actually. There you go. Um, there's some very important thing about dancing is that you execute some steps, you reach a goal, you enjoy it, and you have to learn it somehow. So to me, it's like security, right? You have to learn it, you have to learn from someone, you have to execute, and you have to get to the point where you enjoy it. That's it. So that's about generalities. Um, we are Avatar, and we are hackers. So I'm myself is the least hacker of the group of my group. We are coming from Crisis Lab. Maybe you heard our name. We are also doing CTF. If you ever do CTF, you know the name Spam and Hacks. We do the Spam and Hacks team as well. And there's a famous investor called Mark Anderseen. You know the name Mark Anderseen? No? You know the name Netscape? Maybe, yeah, Mosaic. Now he was the one who invented Mosaic and yeah, Mosaic browser. He was the godfather of browsers. Okay. After that, he turns an investor and he says, like, let's put some money into this IT thing that seems to be interesting. And he puts this famous quote in 2011 that software is eating the world. And if you see the economy changing, actually, all the economies, all these all the topics, all the subjects are digitalized now. And this is a very big generality. But here comes the problem that education and people have a hard time to keep up with this, right? There's always this famous quote, there is not enough skilled programmers and so on. You might agree or you might not agree, but it's true that the more the world is becoming digitized and software based, the more not only the users, but those who produce this whole stuff have a hard time to catch up. And I'm going to shoot a couple of buzzwords here. So I say we need more skilled people, but not only skilled people, we do believe, and this is our fundamental mission, that each and any of these people have to have at least a basic understanding of security, okay? And I'm gonna show you that this is not the case today. And this is why we are where we are right now. A lot of bad software, okay? So why is this important? And this is something might be trivial to you. There's a lot of buzzwords, new technologies coming up. For example, IoT. Everyone talks about IoT. Security is a nightmare for IoT, right? You do agree that IoT is becoming widespread, and one of the biggest concerns people not using IoT because they say, hey, I'm going to get hacked, and actually they do, right? If you remember, recently that was in the news. Some lame people installed like baby monitoring machines, and some hacker got into it and abused the baby. And I was like, come on, we cannot allow technology to be like that. I don't want my kid to be exposed like that. And my kid is definitely not a hacker yet. So he's 2. So IoT is a big thing. And I mean, monitoring is one thing. It's serious enough. But if you talk about pacemakers, who heard about Barnaby Jack? You all did, I hope. I want to see at least some hands. Okay, so Barnaby Jack is a very brilliant, at the same time, very sad story. I think it was 2013, 12, when he demonstrated that you can deliver a deadly electrical shock to a person's pacemaker because it's remotely controlled. So what he did was very interesting. It was a typical IoT problem. So it turns out that there is a bedside unit for these patients you can hack into. So it's with a simple ping, you can get the serial number and the version of that device. Unfortunately, everything is default setting. We know this pretty well from Mirai these days. Everything is default setting. He hacked into it, he updated the firmware, and he was able to do whatever with the patient. This is scary. Not only this, it turns out that these devices communicated with the server to download the firmware not only download, they uploaded. So he demonstrated it's possible to take the firmware, which he modified, and upload it to the central server and possibly to push it to all these devices around the world. Now, this is a very scary prospect, and I don't want to be a pacemaker patient after this. You can imagine. So this is something you and I and we all have to do about. So do it better. Another thing is self-driving cars. Another big hype, like, hey, that's cool. I jump into the car and it brings me to my destination. So I don't even need a cab or even Uber, right? It's my car is going to be my Uber. Unfortunately, cars can be hacked. And this was demonstrated by Charlie Miller and others. And this was demonstrated partially by us. So we had a presentation at Hacktivity in Budapest last year. Where we said, like, hey guys, it's difficult to actually hack into the car. So some people demonstrated it, but it's kind of an elite hackers thing. So why not hack into the computer of the mechanic? That's easy. They are using Windows 7s, Windows XPs, and they are so last century. And it turns out this is not very difficult. This is not very different from the hack that happened in Stuxnet. The mentality is the same. Basically, in this case, you infect a computer that controls a unit. In the Stuxnet case, it was the PLC. In our case, it was the ECU on the car. The ECU is the device that controls all the mechanical things and collects sensor information and so on. So what we demonstrated, and it turned out to be actually very bad. So what we demonstrated is that you hack into the PC of the mechanic, which is not well protected. The mechanics are not experts. They don't care about their computers. And with a simple trick, you can modify after that the protocol, and we were able to switch off the airbag, the street steering, the brakes, you name it. The problem is that these devices are somewhat standardized over the industry. So we demonstrated it on one type of a car. I don't want to mention the name, but after that, the media picked it up, and just for you to see, when you are security researchers, and the first talk was on responsible disclosure, we made a public appearance in Hacktivity. We mentioned the name of the manufacturer, but not as this car can be hacked. We just said we demonstrated it on one car. It could be any cars, because the cars use the same principle. Now, some journalists picked it up from the UK, put an article, and there was a huge, like, this manufacturer is bad, it was hacked. So you can imagine the next day we got a call. So guys, what is this? And since that, we have a somewhat of a cold relationship with this manufacturer. The good thing is that other manufacturers called. So it's like, hey, nice, I heard that. So another of this typical and interesting stuff, and we care about, high impact things, is critical infrastructure. People talk about that a lot. And we did a couple of things. I'm talking about here Crisis Lab, not Avatar, so the two are related. What we did here is, first we discovered Dooku. If you heard about Dooku, maybe? Okay, so we discovered Dooku. It was a malware deployed at a certain company. It was a CA, I can say. And it was used to monitor the information flowing through that CA. And it turned out that it's very similar to Stuxnet, and similar to the point that they had code parts that were exactly the same. So we put out a report, and we demonstrated that it is the same, and people started to recognize us. And for us, we are here in Eastern Europe, so for us it was a really revealing experience when you publish a report, and first of all, it's not a vulnerability disclosure like 2 pages. We are researchers at the university, so we tend to be a bit scientific. So I think it was a 60 pages report with all the details and everything, joined with a vendor. And people started calling us, and the first question was like, so where is Hungary? So what are you doing there? And the second of all is like, who are you? And it's like, okay. And the good thing is that since that, people pick it up, and in security, it's very important to build a trust relationship, because since that, if we talk to these researchers, like name the big companies in security, and there is an email address, when we write that, they actually respond. They say that there was a recent incident when we reported something, and within two hours they said, like, we checked the whole code base and it's not there. And this was the change from A to B. So after Dooku, we did some work on Flame, and people kept writing like books and stuff, weird things. What is the next thing I wanted to point to you is that it's this is what salespeople like to say is like most of the vulnerabilities are attacks are via websites and so on, and this is true. The problem is here that in the media usually the big shots gets publicized like shell shock and heartbleed, and this is serious stuff you should be protected against. What they don't say is actually that most of the problem doesn't come from these high profile attacks. Most of the problem comes from the very, very basic attacks. And here I'm slowly getting to the point, actually, we as hackers, or can I say we as hackers? So we as hackers care a lot about this very specific and very targeted and very, nasty and very, very sophisticated attacks. But for the world, this is not causing the problem. For the world, it's still a vast top 10. And this is a key message. How do we fix this in the world while still caring about shell shock and all the others, but the fundamentals are not fixed yet. And it's not about websites; it's about the apps too. So most of the apps are actually faulty, and this leads to bigger attacks. If you heard about the Target attack, you heard about the Target attack. Target, you know what Target is? Some people say yes. Okay. Here are the typical attacks. How these organizations get attacked. Now the important thing is here that some of the organizations are actually prudent. Now in the case of Target, it wasn't the case. They had very good vendor products. They bought all that expensive stuff. They outsourced the monitoring to India. And I'm just saying that actually the monitoring was pretty good. The product detected the malware that was deployed. The Indian team reported back to Target, and they didn't care. And it wasn't that they received alarms of hundreds of alarms per day. It was just that they were negligible. What I'm trying to say here is it's no matter what technology you have, it's the human at the end of the day who decides who has to do it properly. Same for JP Morgan and Chase. Their security was pretty good, but they had a vendor, a third-party vendor with a web application that was not very good. And I know that a lot of companies these days are doing, some kind of auditing and testing on the vendors, but it's very difficult to do it to right to the bottom. And another case is here, Community Health, that as soon as Heartbleed came out, they got hacked. And this is a particular case because healthcare data is not like any data. You might say like your credit card data is serious. Well, think about your healthcare data. You can change your credit card. You cannot change your healthcare history. It's all about you. So let me just go to this more. So what is the process to fix it? First, well, you should write secure code. I do believe that fixing retrospectively, it's a lot of effort and it doesn't pay off. I'll show you why. So here's the typical secure software development lifecycle. You plan properly, you execute properly, you test properly, and it's a long cycle. What's the problem here? I showed it in blue, that hackers, the experts, come in almost at the end, right? And for companies, this is really costly. I do argue, and this is just to show you some numbers. These numbers might be a little bit more down by the time, but if you can catch problems at the beginning, so really teach people who produce the code, it's much, much better than employing a lot of hackers. I don't want to take your jobs. What I'm saying is that you guys, hackers, you are expensive, right? And to be honest, like those of you who are pen testers, you know exactly if you have a job, if you have an auditing job, and you found the N+ first SQL injection vulnerability, you are like, come on, guys, don't do the basic mistakes. And this is a serious problem because here we are wasting brain power. Here we are wasting serious money. So we should focus at the beginning. And what we can do is, of course, code Code reuse has to be taken very, very cautiously because, as we saw with the reusing of, for example, OpenSSL, that if you use even very basic code, can be the entry point onto your security architecture. You should always do a careful debugging. And one particular example I always tell my students is rubber duck debugging. Who knows rubber duck debugging from you? Very good. So if you ever want to teach this stuff, then what I do for my classes actually is that I buy them these ducks and I give them on the first class. It's like, use them. And you would be surprised how much it improves code. A lot. Now, you should always do code review, but do it first yourself and then do it to the other people. There's a very good measure of code review quality. It's like the WTFs per minute. And of course, pair programming, and except for Chuck Norris, we usually do it in pairs. Another thing is that there's a lot of tools, use them. It is surprising how many developers cannot use basic security code testing tools. And one last thing is, since some of our team is from crypto, never, ever design your own crypto unless you know what you're doing, okay? A lot of people tried, a lot of people failed. We've seen applications where they said, oh, wow, we designed this cool, whatever, authentication method. No, don't do it. So people speak a lot about the major problem. This we are lacking people. So what's the solution? Let's start security coding boot camps. Let's start curricula that develop more coders. Well, it's good. We should have more IT people and developers and programmers and even hackers. But it's very important that these guys actually understand what they're doing. Okay? And you should say that universities solve the problem. Well, they don't. There was a recent survey that showed that, for example, in the US, you can graduate from top universities, almost all of the top universities, without ever having a security course, ever. And these guys go out and be software developers, architects, or whatever. I'm not saying they don't pick up the knowledge after that, but it's just not common. And this is not surprise. Sorry to have this a little bit of this education side of the problem, but this is how we teach security. Do you think that these people will learn security? No, because they are listening to something that's written on the whiteboard. And sometimes you can learn it after that on the job. But since security training is actually very costly, it only gets to a very few people, usually the top people like you, hackers. You get the knowledge, you self-develop yourself. But for the rest of the people, those who produce the applications, those who write the websites, they don't get this training. They still are stuck with their university skills, unless they're really, really pushy and they learn it themselves. The other thing, it's not fun. I mean, if you go to the hacking village, there's a lot of games, and there's DCTF, so hacking and security teaching should be fun, right? And most of the trainings are not like that. Some of them are, but how do you scale it up? So we got to the point of Avatar, just at the very end. So let me show you this a little bit. We created this platform to actually let anyone to start playing and learn. Okay, and it's no rocket science. It's just a collection of hands-on practical exercises. Now the good thing about this is that it works. It's quick. So you open your browser and you start hacking. That's so easy. We realized that a lot of people don't know how to use security tools. And it's not a problem because sometimes they can learn, but it takes some time to set up things. So in our case, we put up like tool tutorials, Unicorn Engine, Wireshark, Nmap, just name it. We started with a couple of these tools, and we take these people step by step in a challenge style. So you solve the things, you submit a solution, you get further, you challenge yourself, and you go, and at the end, we plan to arrive at a use case scenario. We also create hacking exercises. We do participate in hacking exercises. This is DefCamp last year. We are the finalist team. But most of all, and this is our really the mission we wanna pursue, we wanna teach security to everyone. We don't believe that security belongs to the elite hackers. Security belongs to everyone. Security belongs to the last software developer who just graduated and has no idea what an XSS means. Okay. So I would like to ask you to actually join this community. We created a custom CTF for DefCamp. You can come to our booth in the Hacking Village. Try the CTF. Just try it for yourself if it's for you or if it's not. And we have in the platform a variety of exercises. So anything from web security to IoT security, embedded security, all that stuff, all running from the browser. So it's up to you. Try it. Thank you very much. If you have questions, shoot them. Do you have the mic? There's a question. Or if you can shout, that's okay too. So yes, so there are development tools to actually avoid this problem. The problem is that those who develop, sometimes they don't know the tools, they don't use the tools. So we do believe that there has to be like it's almost like a driver's license for development. So you have to know the basics, and to avoid this kind of errors, exactly what you say. And even if you have websites, what you mentioned, that are vulnerable, I mean, just fix them. And that's actually a community thing. And here we come back to the issue of bug bounties. Bug bounties are actually a great thing, but that's for rich companies, right? So I do believe that actually bug bounties should be pushed down to the level of a random website. So people should be able to report this to the website's developers and say, you should fix this kind of things. Did I answer your question? Okay, thank you. Other questions? If not, you can find us in the Hacking Village. Just talk as much as you want. Thank you very much.